Welcome back to the last session of this chapter, that is units and dimensions. Friends, in the previous video we understood the dimensional analysis, and in that the applications of dimensional analysis. There were three dimensional analysis or applications were there. Out of three, one we have understood, that is checking the consistency or the correctness of equation of a given equation. So we saw three important numericals or equations: s equal to ut plus half at square, v equal to u plus at, and v square equal to u square plus 2as. Three things we have understood. I suppose you solve the third homework as given as a homework: v equal to u square plus 2as. And today we are going to understand the next application, that is reducing the relation among the different physical quantities. That means what here, he will give you a simple fundamental equation or simple fundamental relation in terms of physical quantities, and we have to express it via the mathematical equation. So physics is converting into mathematics. How exactly this will work? Let us start one by one by taking a simple example. Simple example says that a time period t. They say here, I will take an example. This is the only one example which is mentioned in our textbook. The time period of t of a simple pendulum depends on t is depending on a mass of the ball. Right? T depends A means time period. T depends on a mass of the ball. Ball. So it is small m. B, length of the pendulum. You are going to measure the time period, length of the seconds pendulum, mass of the ball, everything you are going to measure in the laboratory. So no need to worry about this in detail. So only you have to understand theoretical concept, practical aspect you understand in the laboratory. And acceleration due to gravity. Three things they have given here. So what they have given? First they have given the time period of a simple pendulum depends on mass of the ball, length of the pendulum L, and acceleration due to gravity G. Three things are given here. So now first and foremost we have to express in a mathematical way. What they say here, D is directly depending on this, D is directly depending on this, D is directly depending on this. What is the meaning of this? If mass of the ball increases, mass also increases. If length increases T, then T is depending. How exactly? Let us start one by one. I don't know how it is the exact relation. So let me start one by one. So according to, or let me write, let T is depending on. T is directly what is depending on? It is depending on m raised to x. How many times I don't know? So m raised to x, then L raised to y. M raised to x, L raised to y, then G raised to z. I don't know how much it is. G raised to z. This is depending on like this. Alright? This is inversely proportional, directly proportional, that we don't know. So we have to express this quantity in a mathematical way. So afterwards, remove the proportionality constant. So if I remove the proportionality constant, I don't know what the value. Let me write K. K is equal to K into m raised to x, l raised to y, g raised to z. So let me write that one also. So this is y, this is z, and this is x. Now in this we have to express all the quantities in terms of dimensions. How to express in terms of dimension? To express in terms of dimensions, let us start one by one. What is the dimension formula for time period? So here only it is also with the time, only t is there. So now no m, no t. So I can write here. So dimensional formula for equal to what I know, m raised to 0, l raised to 0, p raised to 1. This is first one. So first thing, say now this is equation number 1. Second one, mass. So if I write this, I don't know what the value of that becomes. M raised to x. Is m raised to x, not m raised to x. Then next, m raised to x, whatever known as length. L raised to y, this becomes L raised to y. Similarly, acceleration due to gravity. Acceleration due to gravity. This is very, very important. The SI unit of acceleration due to gravity is meter per second square. So hence it becomes 0 raised to that one is r. Acceleration meter per second, L comes into picture. Then t raised to minus 2, then raised to z. Units of price is how it is. G is in meter per second square. G is in means G is measured in meter per second square. Meter means length. Second means t minus 2 as z. Now I am going to substitute the value. That is this value, all this value in equation 1. Substitute all this equation in 1. So equation 1 implies. So if I write this equation 1 it implies. So equation 1 is here. So t in the place of t what I write? M raised to 0, L raised to 0, L raised to 1. So it becomes like this. M, L, T. Values are, this is 0. This is again 0. And the value of t is how much? Plus 1. So plus 1. This is 1. Why I am using your means you understand in a better way. This thing. Afterwards, mass. This one I have to write like K into K as it is. First thing is I have to write first what is M? M as it is. The next one is L as it is. Third one, acceleration due to gravity. What is that? L t raised to minus 2. Wait, I will write the indices 2. So now M is expressed in terms of x. I will write this as a x. Then L is expressed in terms of y. So I will write here y. Then Z is expressed as G. Z is expressed in terms of how much it is. So G is expressed in terms of Z. Afterwards, then one must continue. M as it is, then raised to 0, L raised to 2, L raised to 1. So now this is K as it is, M raised to X as it is, M raised to X, I will just write it as X. X here, is 0 here, then 0 here, then 1 here. Then I have to solve this, very, very important. Then if I solve this, I get L raised to y, then it becomes L raised to z, t raised to minus 2z. Right? So I will use the color to understand it better way. So now it is y. It is y. Now it is z minus 2z minus 2z. Again, here is law of indices. A raised to m, a raised to m, like this. So again, I have to modify. So again, if I write this one, I get m, l, t, close the bracket, is equal to k into m raised to, then l raised to, then t raised to. So you get it right? Step by step. This is anyway 0. This is 0. Sorry, this is x, no? X. This is 0. This is 0. Now, this is y, this is z. A raised to m into a raised to n equal to a raised to m plus n. This becomes y plus z. Y plus z. Afterwards, t raised to minus 2z as it is. Minus 2z as it is. Afterwards, equate. Look at this. If we ignore the constant value, look at this. x equal to what? 0. L equal to what? Y plus z. T equal to what? Minus 2z. This is 1 only. So 1. Compare the indices. Compare the indices or powers. If you compare the indices, we get what we get? We get x is equal to 0. X equal to 0. Y plus z is equal to 0. Y plus z equal to 0. Then minus 2z is equal to plus 1. This is very important. Minus 2z equal to plus 1. So then if I rewrite this one, I get z is equal to minus 1 by 2. Z equal to what? Minus 1 by 2. Then substitute z equal to minus 1 by 2 in the above equation. So this equation implies what happens here? Y minus 1 by 2 is equal to 0, because in the place of z I use minus 1 by 2. So it is 1 by 2. So if I rewrite this one, I will get y is equal to what happens? Plus 1 by 2. Plus 1 by 2. Now I have obtained the value of x, y and z. The value of x is equal to 0. Now I have to write it step by step. X equal to 0, y is equal to plus half, then z is equal to minus half. Now taking all these values and substituting in equation number 1. So once you are substitute in equation 1. So if I substitute in equation 1, then equation 1 becomes t is equal to k into m. M raised to m. What is the value of m? M raised, I don't know the value of x. X is equal to 0, but I have write this m raised to 0. Afterwards, L raised to y. L is there. What is the value of y? Plus 1 by 2. Then g raised to z. G. What is the value of z? It is minus 1 by 2. So anyway, this is m raised to 0 means nothing is there. So it becomes 0 only. Or sorry, it becomes 1. Anything raised to 0 means what? 1 only. So I will keep 1 and remove it. Then finally, t is equal to k into L raised to half divided by g raised to half. You may surprise with this too. I have taken this associated with the minus sign. That's why I take it to the numerator. It becomes plus. A 1 by a raised to is equal to what? A raised to minus m. So I have taken like this is also 1 by 2. This is also 1 by 2. If the power is 1 by 2, is nothing but what? Square root. So then I can write it very happily. T is equal to square root of L by G. This is also square root. This is also square root. L by G square root square root. So I wrote the square root. And the experimental value of K is found that the experimental value of K is equal to 2 pi. It's found that the experimental value is 2 pi. So there is another plot. No need to worry about this. Directly write the experimental value of K is equal to 2 pi. Then first put in application. I will get T is equal to 2 pi into square root of L by G. Friends, this is the third fundamental equation we are going to verify in the laboratory. That is T is equal to 2 pi into square root of L by G. We are going to calculate the experimental values. That is, we will experimentize on this equation. This is simple pendulum experimental. Now, what we did? It is a simple thing. So they have given this problem. That is time period of a simple pendulum depending on the mass of the ball, length of the pendulum, and acceleration due to gravity. Then I express the same thing, mathematical expression. This is a physics expression. This mathematical expression T is directly proportional to m raised to x, n raised to y, z raised to z. So I remove the proportionality by a constant k. Then I wrote the dimension formula for time period, then mass, then length, then acceleration due to gravity up to here. Afterwards, I put all these values in equation number 1. I got this equation. That is m raised to 0, n raised to 0, t raised to 1 equal to k into m raised to x, l raised to y plus z, and t raised to minus 2z. Then I compared only the indices because they say they equal to, they must be equal. Then by this I got x equal to 0, y plus z is equal to 0, minus 2z equal to 1. Simplify this and get z equal to minus 1 by 2. Substitute in the above equation, you get y equal to 1 by 2. Take all these values, again substitute in equation number 1. So you get this equation. T is equal to k raised to l 1 by 2, j raised to 1 by 2. So both are having the square root. So now I can write m by g square root of h. So t equal to k into square root of exponential value of t is 2 pi, then t equal to 2 pi into square root of L by G. So this is the only one example is given to you, but I will give one or two more examples of this kind as a homework. So no need to worry, I will send in the PDF format and you can copy your notes. Now, last thing of this chapter is, demerits or what are the limitations to the dimensional analysis. I can write here limitations to the dimensional analysis. Limitations to the dimensional analysis. Dimensional analysis. Friends, to understand the limitations to the dimensional means, so only a certain extent we can have this dimensional analysis method. Beyond that, it is not possible. Let me give you only the limitation. Beyond that, it won't work. In what condition it will work? So let me start one by one. So now, in this equation, in the present equation itself, you see, look at this. 2 pi. It won't talk about 2 pi. Where 2 pi is what? It is dimensionless quantity. So it won't talk about the dimensional quantities in a given equation. So hence, it fails. It will definitely give the relation between t and L by G. But out of this 2 pi. So it won't talk about it. It won't give any information about the dimensionless quantities. And also it fails to give the relation between give the expressions for, or it fails to give the information about the trigonometric functions as we studied in mathematics: sin theta, cos theta, tan theta, cot theta, cosec theta and sec theta. About this, it won't give any information in the dimensional analysis. And the exponential value, a raised to x and logarithmic values. So it won't give any information about these values, that is trigonometric function, exponential values and the logarithm things. And afterwards, it won't talk about any dimensional, it won't give any information about the dimensional constant. If I give a simple example, in the previous video we discussed we checked the correctness of a given equation. There we solved two important equations, that is s equal to ut plus half it square, or x equal to x naught plus v naught t plus half it square. What about half? So we compared only the dimensions of x naught, v naught t and it square. We never bothered about half, where half it comes. So it won't talk about that constants in a given equation. And second thing is v square equal to u square plus 2as. So we compared only the dimensions of v square, u square and as. What about 2? So it won't give any information about the dimensionless quantities. And it won't give any information about pure numbers. Like if you say, in a constant, in a given equation, if you use any constant like pi, we know the value of pi 3.142, but it won't give any dimensional, like as I said in the present equation just a couple of minutes back. So it won't give any information about that. Then look at this. After examining all this thing, I wrote this constant directly, k equal to 2 pi. How it came, we don't know. So in this present case, actually we know, but time being, in this method, in the dimensional analysis, it is not possible to calculate the dimensional constant. It is not possible to determine the proportionality constant. This is one more drawback or one more limitations. And afterwards, if any physical quantity is beyond this means, look at this, our restrictions itself in this present equation m, l, t, mass, length and time period. If it exceeds more than 3 physical quantities, again it is difficult to analyze, or it won't give any information about if any relation is depending on more than 3 physical quantities, that is mass, length and time period. And finally, so it won't talk about the scalar and vector quantity of physical quantity. So a physical quantity is given and the dimensional analysis will not give any information about the physical quantity, whether it is a scalar quantity or a vector quantity. So totally hardly 6 or 7 limitations are there. Already I explained, all 6 are explained, 6-7 points I explained, but it takes a lot of time to write, so that is why I am just explaining. So I will give in the form of notes. So I will send the PDF file. Do copy the PDF file in the notes book, right? Afterwards, next day I will send one more question bank, that is assignment questions you write in the assignment book. So with this, I am completing the second chapter, units and dimensions. Thank you, friends.